Hello, everybody. My name is Rafi Karlansik. I am a solutions architect here at Databricks, and today I'm going to be talking to you about how to automate the machine learning lifecycle with the Databricks platform. And our agenda today looks like this. We're going to start off, I'll give you a very, very brief introduction to the Databricks platform, and in particular, Databricks machine learning. Then we'll talk a lot about task automation. I'll have a pretty deep dive demonstration for you into what that looks like and what that means. Then after that, we'll talk about pipeline automation. We'll have a brief demonstration of that. We'll kind of round out the automation talk with how to do CI/CD with Databricks repos. And then we'll conclude, summarize everything we talked about, and hopefully we'll have time for a few questions. So let's get started. If you're not familiar with Databricks up until this point, let me just provide some context and some insight into what kind of a platform Databricks is. So Databricks is a lakehouse platform. And if you're not familiar with that term, you haven't heard that before, it's a portmanteau of data warehouse and data lake. So what is that concept? Why are we doing that? In order to understand this, we need to consider what's unique about data warehouses and data lakes and where they have their strengths and differences. So data warehouses are typically really, really good for working with structured data sets and for doing BI and SQL type reporting and those kinds of workloads. Been around for a very long time. They excel at that type of analytics. Data lakes are a little bit more recent phenomenon, and they have some unique qualities to them, namely that they can support many, many different kinds of data in addition to structured data types, as well as real-time streaming applications. Another hallmark of data lakes is that they are open. They tend to be open source technologies. So then what's this concept of a lakehouse? The idea is that we can bridge the gap between those two worlds, and we can support all of these different analytics use cases on a single platform, a single copy of the data. And the way that we do this with Databricks is through Delta Lake. So Delta Lake is kind of the key technology that makes a lakehouse possible, allows you to kind of unlock all these different use cases in one place. So this is not a talk about Delta Lake. This is not a data engineering heavy talk. There's plenty of other information out there on what a lakehouse is, but for those who may not know, I just wanted to give you that background. Now, in particular, though, we're going to be focusing on the data science and machine learning capabilities of the Databricks Lakehouse platform. And what I really wanted to call out here is that when you're choosing a data science and machine learning platform, it's well worth it for you to choose one that is data native or data centric. Meaning that the same place that you're doing your exploratory data analysis and your model training and model serving is the same place where you do your data management more generally. So a lakehouse platform is perfect for that because we have the capability of providing whatever kinds of data that you want to use in your data science and machine learning initiatives, but you don't have to export that to any kind of external system. You don't have to write back to wherever you're managing your data. It's all in one place, so we've unified it in that way. So that's kind of the Databricks machine learning as it sits on the Lakehouse platform and what that concept is. Now, with that being said, let's talk a little bit about automation, the reason why we're here today. So if you can think back to when you first started practicing data science, you can remember your very first development cycle. And it probably began with a line of business leader or your manager maybe coming to you with some sort of business question and asking you if you could solve this with your data science powers. The very first thing you would do then is go look and see, well, what kind of data sets do I have available to me? You would explore them. And assuming you came up with an understanding that led you to believe that maybe we could actually solve this problem with machine learning or with advanced analytics, then you would go to the next step, which would be feature engineering. So feature engineering is the process of taking that raw data and transforming it into some format that can actually be passed to an algorithm to train a model. So once we've gone through that step of transforming the data, we've gone through feature engineering, then we'll move on to model selection. The idea here being that we'll try lots of different algorithms, we'll tune them, and we'll come up with some model that's the best one out of all of them. From there, there's another step that takes place, which is model validation. And this is distinct from cross-validation or hyperparameter tuning in the sense that this is more about external systems. This is, does this take your model back to your manager and go over it with them and see if this actually meets the business criteria. If you work in an industry that has a lot of regulations, make sure that it actually satisfies those regulations. Assuming you pass all those tests, then you can move on and actually deploy your model and make predictions and hopefully add a lot of value to your business. And there's a couple different ways that you can deploy a model. Typically, you would start off deploying it in batch mode, or you would just run it manually as a batch job. You can also deploy it as part of a streaming job, though, as well as online for inference, like as a web service. Now, the artifact of all of this is a particular model object, right? And once you've gone through this and it's been successful, over time, you're going to have to go back and read the latest data and make sure that it still conforms to the business case and actually makes sense, and so on and so forth. So this is an iterative cycle. This is great. There's a ton of value to be gained here, right? There's nothing really new, but this was the first thing that you were doing. So these are really, really great first steps. But what happens if you kind of don't think about where this goes in the future and how, if you were successful, what is the world going to look like? And, it may not be that great in terms of the consequences if you don't think about that. So to start to think about this a little bit more carefully and how we can scale this, I think it's important to ask the question, which of these components would we want to automate and which would we not want to automate? And in particular, I want to focus actually on that last half of the second question there. When should we not automate in general, right? And as software engineers and data scientists and people working in technology, we're usually trying to automate things, and it would be good to stop and ask ourselves, like, well, when should we not do that? So I think there's two main reasons that I came up with anyway, that we would not want to automate. And the first one is like the technology is just not even there yet. Even if we wanted to have a robot that could, turn this faucet for us here, it just can't do it. So technology is not quite there yet. But the other case, though, is even if we could build something and automate it, it doesn't always mean that we should. So if you go on the internet, you could find plenty of terrifying robots that someone may have built that they probably should not have. And I don't know about this one in particular, but the idea is that even if you can do something, it doesn't necessarily mean that you should. Sometimes we need to have a human in the loop. Okay, so coming back to our workflow here, which one of these will we not want to automate necessarily? I think certainly the first one is not there yet. While you may be able to have some machine learning or some recommender that would suggest to you different questions that maybe you want to address for your business, ultimately a human is going to decide which one of those is the one to use, and even that I think is a far-fetched thing. For the most part, humans decide what business initiatives to take on. But what about these other pieces though, right? What about these other four? So I think when it comes to feature engineering, let's start there. You actually have open source tools that will do a lot of automated work for you in generating features. They'll figure out which columns, which variables in your data sets have structure that would lend themselves to being good features. So you have Feature Tools, which is an open source library. You also have Feature Factory, which is a project from Databricks Labs. And then of course, in the past couple of years, you have the whole rise of like the feature store and that concept of being able to have specialized data management for machine learning. There's a level of automation there as well. And then of course, when we move on to model selection, you have, it's been around for a long time, you have sort of built-in functions for hyperparameter tuning, built-in functions for cross-validation. You don't have to write these things yourself, and they help you automate the process of finding the best model. Now with AutoML, this is a very interesting topic because you do have some solutions in open source, but this is a very commonly it's a commercial solution. The idea being that we can explore all the different model types for you. We can figure out what the very best model is, and then just spit out that one and give it to you. So there's definitely some automation to be had in these tasks, right? In the first two tasks. But what about the last two tasks? What about the model validation and deployment? So this gets a little bit tricky because these are actually starting to deal with external systems, right? Up until this point, we just had our data and we were working with it using open source libraries, and we were very much self-contained here. Now we're starting to talk about like, how do we communicate with the business? How do we communicate with regulatory agencies and satisfy those criteria. That has nothing to do with training a model per se. That is a metadata problem. And then number 4 here, this has much more to do with handing off a model to another team potentially, or taking a model and putting it into a different piece of infrastructure. So again, there's kind of this interaction with external systems that we need to manage. So how are we going to automate this? So remember I said before that over time, this is going to become more complex, right? Let's imagine that our model was successful and that it needs to be updated every week in order to be current and actually continue to serve the business. So every single week, you open up your laptop, maybe you're using Jupyter, maybe you're using RStudio, and you go through and you walk through this process yourself. You manually run every single step here. You wind up with this model artifact. You go through the process of meeting with your manager, ensuring that it meets the criteria, and then handing it off and making predictions and so on. And then the next week you do that, and the next week you do that, and so on and so forth. Now, let's say we go through maybe 6 months later, and you have a couple dozen models that you've generated, and someone comes to you and they say, hey, we were looking at the results from week 3, and there's some things that we didn't quite understand. We wanted to actually go back and see what happened. Can you give us some insight into what happened over there? Now you might be thinking to yourself like, wow, I really wish I was tracking that. That would have been really good to know. It's going to be difficult to go back and get that information. So how can we manage this in a scalable way? How can we do that? Now, you might be very, very tempted to use spreadsheets. I know there's times where I definitely really enjoy using Google Docs, Google Sheets rather, and Excel. They can be really handy and quick in a quick and dirty way. So maybe we could potentially use these. No, you definitely do not want to use these. Highly recommend not using spreadsheets to track all the metadata associated with your machine learning and your data science practice. Instead, what you should use is MLflow, because MLflow is a super scalable open source project for model lifecycle management and metadata management around machine learning. And we're going to get pretty deep into how MLflow works and serves this aspect in a few moments. But at a high level, the workflow would look like this. When you're doing your model training, you'll start using MLflow to track all the various parameters and metrics and artifacts that are being generated while you go through that process. And then you'll take the best model, you'll commit it to the model registry, and then that's where it would basically live and get deployed to your however you're doing inference, it would be deployed from there. And that's where you'll manage that particular best model throughout the rest of its life cycle. Now, there is a pretty deep way in which MLflow can help with number 3 here, and we're going to go into that. But if this is the first time you're kind of being introduced to MLflow, I want you to sort of think about tracking, experimentation, and the model registry where you are managing models that are in production or the best models throughout the rest of their life cycle. We'll talk more about model validation in a minute. Okay, so now that we've kind of gone through all that and we've understood a little bit about automation, we've introduced MLflow, let's actually go take a closer look at how MLflow can do this, what that actually looks like. Okay, so here I am in a Databricks notebook. And like I said before, we can think of MLflow as kind of having these 2 different pieces: the tracking server, where we track all and we log all of the results of our experimentation, and then the model registry, where we take the best model and we promote it or commit it to the registry and then use it for the rest of its life cycle. Now, in this example, I'm going to take you from like the most manual way, I would say, to begin logging this information programmatically, all the way through to a very, very automated way of doing it. Now, the example that we're going to be using here is going to be a data set on trying to understand which customers are going to churn. So we're going to try to predict which customers are going to churn so that we can save revenue. And this is very much like boilerplate data science code here. We're just splitting data into training and test sets, and we're getting ready to use it with scikit-learn. Okay. So let's get right to it and show how we can use MLflow to begin collecting this metadata around our model and the artifacts and stuff like that in an automated fashion. So the first thing we're going to do is set the experiment. This is where all the runs are going to be logged. And then we'll begin a training run. In that training run, we'll fit the model. So we're using scikit-learn right here. And then we'll get the metrics for this particular run. And we'll log, using MLflow APIs, we'll log the parameters and the metrics and the model itself. Okay, so let's run this cell. Okay, great. So we logged one run to an experiment. If you'll notice up here in the corner, we have in our notebook the results of this particular training. So we logged the mean accuracy, right? And I came over here and I specified, hey, I want to log this particular metric, and here's how I generated it in my code. Okay, great. This is fantastic. All the things that you're doing already to check accuracy and different parameters and things like that, you can simply use these APIs. You can wrap it around your existing code, and every single time you train a model, it will log these results here to MLflow, and you'll be able to explore them. But there's an easier way to do this, actually. So with Databricks and autologging, we don't need to write any of that code at all. We could simply use mlflow.sklearn.autolog and then run that exact same model fitting code, and then watch what happens. So our experiment has been updated with a new run, and look at all this information that I have. So this is way more information than I would have had by coding this by hand, and this is all the data that comes from using this decision tree classifier in scikit-learn itself. So those are our accuracy metrics. Here are our parameters. Grabbing all of that for just immediately, automatically. Now there's one additional level here where we don't even need to use this single line of code. So there is a setting that we can use at the workspace level. So this entire Databricks environment, we could simply just turn on autologging. In the workspace, it's known as autologging. And then we don't even have to write that. We don't have to use any MLflow code at all. We could simply use this, and then it will log another this run to MLflow, as you can see up here. Okay, so that's fantastic. That's some great automation. Let's just take a quick look at our experiment view, right? And we can see all of the different runs that we've gone through so far. So we have the first one where we like hand coded it, and then we have the other two where we're using MLflow autologging on Databricks. Some other really nice things here. This is the tracking server that we were talking about before. We also autologged some plots that basically describe the accuracy of the model that was trained. And then we also have the model object itself is saved into cloud storage, and we can use this and load it back into memory later. We have some examples here, some code examples for you. There's more metadata that's being collected here, and it's worth pointing this out. So we have the input schema and the output schema for this particular model. So now we know ahead of time, these are the data, these are the columns, and these are the data types that this model expects, as well as what the output of the model is. Furthermore, come up here, you see we have the ability to add notes. We have tags. In particular, one that's worth calling out is the data source information. So given that we were using Spark to read this data source, to read this data set, so we have that logged as a tag associated with this particular model, in which version of the data that was associated with it as well. So there's a lot of very rich information here that's being collected with autologging in Databricks. That's fantastic, and we're using MLflow. Now, before we get to the registry, I want to talk a little bit about how we can like supercharge this with Databricks AutoML. So let's come over here. What I've done to start an AutoML experiment is I came over here in the machine learning section of Databricks. Okay. We'll come over here to create AutoML experiments, and then we'll be brought to this page. So now at this point, I'm going to walk you through how we would go about setting up an AutoML experiment. We'll select some compute. We know we have a classification problem. We're trying to predict whether or not someone's going to churn or not. let's go get our data set. These are the features that we have after our feature engineering. We're going to predict whether or not this customer is going to churn, and everything looks good. We can come in here and specify what metric we're trying to optimize for and what the stopping conditions are, but we'll just go with the default for now. Okay, so now this looks kind of familiar, right? Now we're back in the experiment view of MLflow, but there's some additional stuff going on here. So AutoML is getting going. And as this starts to run, let me start to give you some insight into what's actually happening behind the scenes here. So the way Databricks AutoML works is that we have access to Apache Spark. Databricks is the company that the founders of Databricks created Apache Spark. So we have access to this, massively scalable parallel processing engine. And one of the things we can do with that is we can actually use Spark to orchestrate training many, many models in parallel. And every single one of those models that are being generated, we can log all of those results to the tracking server with MLflow. Furthermore, we use HyperOpt, which is a Python library that uses Bayesian optimization to converge upon what the best parameters are for a particular model. So not only are we parallelizing this, we're going from like that single node like Python workflow where we're just like hitting run and seeing the results come in. We're parallelizing this to massive scale. We're logging everything automatically, and we're doing it in an intelligent way where we'll converge upon the best results. So we have some results coming in. I'm going to let this keep running for a minute. One other nice thing just to point out here is that in addition to, when we're talking about automation, in addition to having these different models be trained, we actually have a full exploratory data analysis notebook that you can leverage with Pandas profiling to basically go over and look at the data set and things like that. So while your model is being trained, you can kind of come in here and do that. So let's take a look at some of these results. Okay, we can see that we have different model types that are being trained here for classification. And it looks like one of them has completed. So we have the metrics and the parameters already coming in. Let's go drill into this particular run. Okay, so we have that same supplementary artifact data that's included there, as well as the model artifact itself. The particular, there's a description of the content environment for the dependencies, as well as the requirements.txt file. Fantastic. We didn't have to do anything for this, right? We have all of this just like generated for us. And what's most interesting here is actually that the way that this works is that we generate notebooks for you. So this is an auto-generated notebook. It's fully editable, and we can come in here and see exactly which types of preprocessors were used, how the different columns were standardized. There's more information on feature importance, as well as how to use this particular model for inference going forward. So there's a lot of tremendous information that's included here, and this is all fully editable and modifiable. Now, this is what we mean when we talk about Databricks AutoML being glass box AutoML. We don't just have some secret sauce and then spit out a model artifact and you have no way to recreate it or change it or anything like that. It's the complete opposite of that. We give you everything, and we use fully open source technology so that you can recreate this yourself. So let's say we've converged upon what the best model is, and now we actually want to go and promote that to the registry. So now this is kind of where we are in that model validation step, right? We want to take a model that we've trained, we think this is the best one, and we want to move it to the registry, but there's that third step there where we want to actually validate that this meets business criteria and things like that. So how can we introduce automation around that? So I want to talk to you a little bit about webhooks. Now, the idea of a webhook is that it's basically an event-driven API call. So when someone, let's say, promotes a model to the registry, that can be an event, we can decide to do something. That can be send a Slack message, that can be call like a cloud function in AWS or Azure or GCP. or it can be, let's go run a Databricks job. So in this diagram that I'm showing you here, imagine that you have two notebooks. You have one notebook that a data scientist is using to promote a model to the registry. They have their best model, promote that to the registry. And then you have another notebook that will actually test the model for a variety of things, including whether it meets certain regulatory criteria, whether it has certain documentation associated with it, whether it just performs accurately on different subsets of the data. You can have a whole notebook that's dedicated to just performing those tests. Now, the way that this flow works is that when a data scientist promotes the best run to the registry, that model will actually move into the model registry, but it'll be marked as none, like it has no stage. At that moment, we'll actually trigger two webhooks to fire. One of them will be a Slack message that says, hey, someone is requesting that this model be moved to staging in the registry. And then the second will be a call to the Databricks Jobs API, where we'll run this testing notebook and actually go get that model and subject it to all these different tests. And then depending upon whether or not that model passes the test, we can either approve it and move it into staging, or we can reject it and archive it and let the person know, like, hey, your model wasn't good enough. These are the things that you have to do to go fix it. So there's a tremendous amount of automation that we can build in here and work really, really easily. So I'm not going to take you through like how to create webhooks. We have a notebook here that we can share. This kind of like walks you through like how to do that, but it's fairly technical, so we're not going to go that deep. Most important thing is just to understand the workflow here and how this would work. Okay, so now that we have the best model and we want to actually promote this to the registry, we can do that quite simply. We simply need to grab the particular run ID for that particular training run that's associated with that particular model. And we need to specify which model name we're going to be associating this with in the model registry. And then we'll tag it with some metadata that's relevant to this particular use case. And then we can just register it using the MFL function right here. Let's run that. And okay, we're creating a new version of this model. This is going to be version 4. Now at this point, this is going to be in that none stage like we had in the diagram before in the registry. And what we want to do is we actually want to use the notes, use the comments that are available in MLflow as part of the metadata and lifecycle management to describe what this model is. So this is one of the criteria that we would want to make sure we test for. So let's include the description. And then let's actually make the request to transition this model from none to staging, because we think this is the best one. And we'll leave a comment in the model registry that has that information. If you're not clear on the model registry yet, I will show all of this, how it shows up there in just a few moments. But for now, let's go take a look at what just happened. So we made the transition request from none to staging, and that triggered both the webhook and the job to the Databricks Jobs API, which you just saw running, and that it just succeeded. So let's go take a look at this. Here is our testing notebook, right? This is another notebook. This task is sitting in the workspace here in Databricks. And in this notebook, we're going to do a number of different tests, right? We're going to grab the model that's being requested to move to staging. We're just going to make sure that it actually makes predictions. And then assuming that it does, we will tag it as such. So we're essentially, as the model goes through all our tests, we're going to be tagging it with the outcome of those tests. And then there's a few different kinds that we do in here. I'm not going to go through every single one. We make sure that there is the input and output schema or the signatures associated with it. We check it for accuracy against different demographics, and then make sure that someone has put documentation associated with this model. We will reject anything that is put in the registry that doesn't have any documentation, and so on and so forth. Now, the results of this is that when we take a look at that particular model and we look at the tags, you can see that it has all of these, all of this metadata associated with it right now. And now if we just flip over to Slack real quick, we can actually see that we've been getting messages here in our model registry webhook test Slack channel that says, hey, someone has requested to move this from none to staging, and it has passed these particular tests. So great way to automate the sort of operational and model validation steps that you need to do for managing these models in production. Okay. Now, this model should be in staging in the registry right now. So let's go take a look at that. I'm going to come over here to back to Databricks machine learning. We'll come over to the model registry. So here are all of the models that we have that have been committed to the registry. And here is ours. All right, so here's our description of the model. Here's the latest version that we just promoted to staging. And if we look at this, we can actually see the tags that are associated with it from the tests, as well as if we scroll down, we can actually see sort of the history of this model in our organization and how it's been tracking. So we initially requested a transition from none to staging, and we left a comment there. And then as a result of our testing notebook, we actually approved that, and now it actually has been marked as staging. Okay, fantastic. So that is essentially what we need to do in order to have this intermediate stage kind of taken care of. Going back to our diagram from before, when we had to we had the problem of being able to manage all this data as it's generated through time. Now we have the ability to do that with MLflow. So during model training, we can log all that information to the tracking server. During model validation, we can automate the testing and tagging of models and keep track of all that in MLflow as well. And then finally, once we have models in the registry, we can load them back into memory and run them either in batch or streaming or online jobs. And we can do this going through time. We can sunset old versions and always kind of like use the latest and greatest, but then go back and look at exactly what happened at the original training time or during a particular run. Okay, so going back and kind of like summarizing the task automation piece, right? We talked about how for feature engineering, you can use different open source libraries for that. We talked about how for model selection, you can use AutoML. AutoML on Databricks is great because it's a glass box solution. We provide all of the code. We use Spark to basically scale this out and give you all that information using MLflow. For model validation, we talked a lot about webhooks and tagging and schema enforcement. And then for model deployment, that's where you would load things back in from the registry. Okay. So now what about pipeline automation? So far, we talked about tasks in a workflow and how for each one of those tasks, we might automate pieces of that particular task, if not the whole task itself. But we didn't really talk about how to automate the entire workflow itself. Now, I want to introduce this idea of a pipeline, right? Which is basically the unit of a pipeline is all of these tasks together. They create something that's greater than just the sum of the parts here. And we can orchestrate these tasks to run as a unit, and it allows us to really kind of mature our practice going from running individual tasks in a manual way to being able to run the entire pipeline in an automated fashion. And we can include, obviously, all the task automation that we have built in there. So let's take a look at what this looks like in Databricks again. And I'm going to come over to the jobs service again. Okay, and let me zoom out a little bit here. So what we have here is a multitask job in Databricks. So how does this work? So each one of these blocks here is itself one of the tasks, right? And let's say for the first task, we're going to ingest data and do some validation on the data itself, make sure that that it's correct, that the schema matches, and all those kinds of things. Maybe a little data engineering work here. And then the notebook that we're choosing is the task to be run. So we're going in and we're picking a notebook. it's worth noting that we can also pick, different kinds of tasks to run. But in this case, we're going to stick with notebooks because that's what's most familiar to us. And we're going to run this on a new Databricks jobs cluster. And that's pretty much it, right? If we wanted to, we can come in here and specify any dependent libraries, or if we wanted to set up notifications, we could do that. Okay, great. Now, this next one here is for feature engineering. So assuming we have all of the data validation done, then we can move on to feature engineering. Then we can move on to model selection. We can use the AutoML functionality in Databricks through an API. So that's what we can actually do here in this step. Get the best model, and then move that model to the model registry. That will automatically kick off that validation step and test it. And assuming that it tests and is successful, then we can actually deploy it and run a batch job to score new data. So we have our entire workflow here, right, that we used to do manually. We have this all mapped out in the multitask jobs here in Databricks. Now, the other thing that I want to call out to you is that we're running this on a schedule. We can run this on an ad hoc basis or an event-driven basis, like you saw with the testing job. But this is something we know we're going to run every week. So every Friday at 11 p.m., we're going to have this pipeline kick off, and then we'll be able to check on the results afterward, just like we checked on the results of the job before. The other thing that I want to call out here is that not every task is created equal. So for data ingestion and feature engineering, maybe we want to use Spark, and we want to, we have a lot of data that we want to process and join and what have you. But then when it actually comes down to maybe for the model selection, we don't need that much memory. We need a lot more cores because we want to spread out the training of the models as much as we can. So we can choose different resources. We can configure different resources for each task. And these are completely isolated from each other. They're isolated both in terms of the compute, but then also in terms of the environment, right? So if we have dependencies that are in one particular task, one particular job, then we can isolate the compute and the environment for that particular job. The same thing goes for model validation. The testing job and then promoting to the experiment, promoting to the registry is a very, very small job. We don't need a lot of compute for this. So in this case, we actually are not using any Spark workers. We're using a pretty small machine just so that we can get that job done. But we want to have it separated from the other steps in our pipeline. Of course, similar to how we would have alerts on a particular task, we can also have an alert on the entire pipeline. And just to give you an idea of how we can build out, this is obviously a very linear flow, but just to give you an idea how we can build out a nonlinear flow as well. Let's say we wanted to make the model deployment dependent upon not just model validation, but we also wanted it to be dependent upon the data ingestion. So you can see now that this is this will only run if both the data ingestion and model validation steps completed, and we can build this out, more complex and more nonlinear way as well. So that is that's essentially what I wanted to show with multitask jobs. So you can imagine, we have this job that runs on weekly on Friday at 11 p.m. It has all these tasks. We have Spark for the heavy compute and for inference, and then we have just a simple Python, machine running Python for the more lightweight tasks. And this is just one pipeline, right? So with Databricks and multitask jobs, we can orchestrate many other pipelines just more generally. And this is really, really great for linear and nonlinear flows. Like I said, you have resource and environment isolation, and you have all the kind of retries and alerting that you would expect from an orchestration tool. So that's how we can kind of level this up and get to the automation of the actual workflow itself, not just the automation in a particular task. Okay, so moving on is our last automation topic for today. We're going to talk about, just briefly talk about how we can incorporate CI/CD practices with Databricks repos into our ML pipeline. So what do we mean when we talk about this, right?
in general, when we talk about CI/CD, it's something that you have to work with what you have and the processes that you have in place. In general, you're going to be reaching out to some other service that you're using for DevOps or for code management. And Databricks is not trying to replace something like Jenkins or Azure DevOps or anything like that. Instead, we just want to make it so that you can integrate with those things and build off of it. So for continuous integration, we want to make sure that you can deliver new code and new features into the pipeline if you're updating a particular task, things like that. For continuous delivery, what we're trying to do is have ultimately a full test of the entire pipeline in an environment that mimics the production environment before we actually update the pipeline that's running in production. So let's take a look at Azure DevOps as one example of how this would work. So let's say you are data scientist, ML engineer, you're developing your code. What you're going to do is you'll have your pipeline, all those notebooks, you'll have them checked into, you'll have them synced to a Git repo with Databricks repos. So this will be living in the workspace. All the notebooks that I was working with, they were all in a Databricks repo. You'll develop on a feature branch. And when you commit your code, let's say you're committing it to GitHub, Azure DevOps will get a notification from GitHub, which will cause it to check out the changes. You can run tests in Databricks in an environment that mirrors your production environment, right? We have that resource isolation that we talked about in the environment isolation. So we can really replicate what we would expect to see in production whenever we make changes and to our code. Once all those tests are done, then we'll pull those back to Azure DevOps. Assuming that they pass, that will trigger a release. And that final pipeline, assuming that runs, then you'll be able to actually update what's running in production that way. So that is a quick workflow on how to do that. I really recommend, there's 2 blogs that have been written recently that go into a lot more detail on this, but I did just want to go over kind of like the basics of what this would be, right? And we have a lot of resources on this. Okay, so to conclude, to summarize what we talked about, right? If we could boil it down to some simple concepts. Automate the tedious things, but don't ever forget to use human judgment. And with regard to developing, right, you can really simplify what you're doing and set yourself up for scale with Databricks machine learning. MLflow is a tremendous asset, not just to an individual data scientist who's trying to keep track of their work, but then also to an organization who needs to be held accountable for the models that they're building and needs to be able to scale this out to many, many use cases. And then AutoML is really, really great for bootstrapping a particular use case. There's a ton of automation built in there. It's all glass box. You can always go in and modify it. Whether you're a beginner or an advanced practitioner, there's something that you can get from AutoML. It'll make your life easier. Then when it comes to actually, orchestrating this entire process, so you can really lean on multitask jobs in Databricks for general orchestration purposes, including machine learning pipelines. And then you can also lean on Databricks repos for integrating with your existing CI/CD processes and sort of like safely and robustly updating the code that you have running in production. So if you enjoyed this and you're interested in learning more, we have a whole series of blogs and talks on MLOps this year. So there's some blogs written by myself and Joseph Bradley and Michael Stelma and Peter Meyer. We also have some talks from Data and AI Summit back in June that will teach you all about how to use Databricks for these different things. A lot of the stuff that we covered today was in some of that. We also have some links here for particular, very detailed guides on how you could set up CI/CD with Databricks and Azure DevOps and Jenkins. And then obviously our links to documentation for the orchestration and repos functions that I was sharing before. And then lastly, if you're interested, you can definitely go and try Databricks for free. We have a 14-day free trial, and you can kind of test all this out yourself. And before we conclude, I just want to say a very special thank you to these collaborators, these other people in Databricks who really, really helped me prepare for this. So thank you very much for your time, and look forward to hearing any questions you may have.
Let me take a look at the questions that you have here. I'm going to go starting from the earliest to the most recent. So regarding the content, like, yes, content will totally be shared. You'll be able to get access to the notebooks and to the slides. There's a question from Anmol Jain at True Data. Where are the artifacts and models persisted? Is there a TTL for persistence? How to monitor cost over time and storage? I'm not sure what TTL stands for, but the artifacts and models are persisted in cloud storage. So depending upon which cloud you're running Databricks on, they'll be persisted there, like ADLS in Azure, S3 in AWS. You can specify which storage you want to use for that. If you're using MLflow in open source, then typically it'll just be on the file system of wherever MLflow is installed. Okay, Mahesh from Microsoft has a question. Can you please help us with the automation script, which is talked about? Yeah, all the resources will be shared, so you'll be able to take a closer look at that. Rax Yang from First Command asked, would you also share the jobs configuration JSON? Yes, I think I can put that into the, I believe I can put that into the repo as well that has all the notebooks. I'll have to take a look just to make sure that there's no sensitive information in it, but that should be fine. It's worth noting that, like, in the UI for the job service in Databricks, there's a, you can basically flip from seeing a JSON view of the configuration to seeing a more, easy to see kind of pretty view of it. Enmol also asks, the scheduling jobs looks amazing. What would be a pro or con over using Airflow for job scheduling? I think that we actually integrate with Airflow, not necessarily, you can use the jobs with Airflow, but Airflow has Databricks operators, so you can use that. I think that if you want to stay on the Databricks platform and you want to use, you want like a general orchestration tool, our multitask jobs are really, really good for that. And I think we're going to continue to improve it as time goes on. So the one thing I would say about Airflow today is that I think it has a little bit more contributions to it, so far. So there are some things, some more nice things about Airflow, like you can look at the last few runs visually and see how it completed and things like that. So overall, though, I think there's multitask jobs in Databricks are really great. I would definitely try them out. Christoph Martin asked, the UI looks great, but how can we do CI/CD on the ML pipeline itself? Hopefully I answered that, but basically check in, have a repo of your code, sync that repo to Databricks repos, and then when you develop on a feature branch, when you commit the code, that should hook into your existing CI/CD process, and you can run tests and so on, like we had in that kind of diagram at the end there. Victor Liu asks, what are the advantages of Databricks jobs over something open source like Airflow? I think that Databricks jobs is a managed service. If you're using Databricks already, it keeps it all in one place. It makes your whole stack simpler. You don't have to manage something like Airflow. That's one thing I would definitely say there. Prasad asks, how to enable auto logging? I should say that the product team probably doesn't want us to call it auto logging. We should just call it auto logging, but it is funny to say auto logging. You can, if you go into our docs and you just look up auto logging, it's a setting at the workspace level. So if you are an admin, or if you can get together with one of your admins and you go into like the workspace settings, you'll be able to see, it's just one of the flags there. You turn that on. So it's very, very easy to turn that on. Maria from Slalom asks, for Python steps like task 3, can we start job clusters that only has the master node? Yes, exactly. That's precisely the idea. You can configure a compute resource that will only have a driver, have a single node, and then you'll be able to just run Python there if you need to. It actually, just FYI, it does have Spark installed. It just runs in local mode. So if you do need to get some data from like Delta Lake or some other source that you typically use with Spark or from the Hive Metastore, you can still use that. It'll still be a single machine. You won't need to use like any more resources than you need to. Let's see. Yeah. So Joseph Lane asks, can anyone provide a link to the CI/CD blogs? Those will be linked in the slides that we share in the follow-up. It's on the very last slide. You can also just go to the Databricks blog right now, and it's a very recent blog. It was from September 20th. You should be able to find it pretty recently if you look at the most recent blogs. Nelson Gee asks, can you compare Databricks and SageMaker? Yes, I can. I will. That's a bigger conversation, but I would say that Databricks machine learning is built as part of the Lakehouse platform. So it's the same place that you will manage your data pipelines for other various use cases. You would be building your machine learning practice, your data science practice in that same spot. So no need to export to a different service. I think that SageMaker is still kind of more or less a data science machine learning workbench kind of tool. And it's, even though it's in the AWS ecosystem, it's still a little bit detached from a lot of it. I think on Databricks, it's much more integrated and much more native. I will say, though, it's important to note that we can integrate well with SageMaker, especially for model serving. And there's a lot of resources on our website and in our docs on like how to actually do that. And it's in the MLflow docs itself. So that's how I would quickly address that question. Let's see here. Is there an SDK to design and deploy ML pipelines on Databricks, or is it JSON files? Oh, I see what you're asking. It is, oh, so that's a very good question. So I think everything I showed today would be essentially, you would use your existing workflow the way you have it, and you can use the Databricks REST API to build the multitask job if you don't want to use the UI. Those would be described in JSON files, the configurations for the multitask job. But there's a deeper question there, which is actually something that Delta Live Tables touches on. So you can build data pipelines with Delta Live Tables that have linkage associated with the flow of data between the different tables. It's a topic that's a little bit too broad for right now, but Joseph Bradley and I and some other machine learning folks here at Databricks have been thinking about how we can start to incorporate Delta Live Tables into ML pipelines. So great question. Stay tuned on that. That's something that we're probably going to be working on in the next couple of months. Okay, Yvette Biggs from Colibra asks, do you have an approach to be able to connect the ML engine to another platform? Yeah, so you can use Databricks Connect to work remotely and use Spark on Databricks. We also have a new way to kind of remotely work with Databricks that's coming out called DevBricks, and that will allow you basically to leverage both Python, R, and Spark remotely from a different machine, but still have the compute happening on Databricks. So I think I understood your question correctly, but that's how it strikes me. Let's see here. Okay, good question from Patrick Schultz. Can you explain what a Databricks repo is exactly? It's essentially a way for you to sync an entire Git project to the Databricks workspace and allow you to check out on different branches, work on different branches, commit code, submit pull requests, inspect like the changes. I would definitely go look at the docs on Databricks for Databricks repos. We'll give you a bunch more information on that. Let's see here. Paresh asks, would you guys like to present for Boston BI user group virtually? Perhaps. Definitely follow up on that one. Let's see. Sorry, I'm just reading. Okay, good question here from Yang Yu. How do you deploy in production using ACI or AKS? So I'm guessing like how do you leverage deploying these models to Kubernetes one way or the other? So the nice thing about MLflow is that models that are logged with MLflow, they also contain a description of the dependencies and of the environment that the model was trained in. And MLflow has functions to build Docker images from those requirements.txt and conda.yaml files. So from there, basically the workflow is, you log your models to MLflow. They contain the information they have the information associated with them of the environment. and then you can build Docker images from that and deploy them to Kubernetes that way. So if you look in the MLflow docs or on Databricks, you'll see some good walkthroughs on how to do that. It's also worth pointing out, though, that many times you don't need to deploy to Kubernetes. You can simply schedule a batch job, or you can use structured streaming and have your models being scored in a streaming mode as well. So is Databricks free for students? There is a community edition, and we have a 14-day free trial. I think if you're a university student, we do have a university program, but I don't know what the details are for that off the top of my head, sorry. Okay. There's a question here from Oscar Rosen. Why Databricks instead of Azure ML? I would say same kind of answer for why Databricks instead of SageMaker. Okay. Looking for questions I haven't answered yet. Oh, okay, here's a good question. What is the difference between Delta Live tables and multitask jobs? Multitask jobs are for general task orchestration. Delta Live tables are for building out data pipelines and ensuring data quality and understanding data lineage and those kinds of things. So there's some overlap, but they're also distinct. And that is, in a nutshell, how I would summarize it. But you can also go, again, look at our docs for more information there. Does MLflow support MLlib or H2O on a Spark data frame? MLflow definitely supports MLlib. I demoed autologging for scikit-learn, but autologging works with, I believe, XGBoost and Spark MLlib and a bunch of other open source libraries. It does work with H2O as well. I don't know if autologging works with H2O, but MLflow does. Is there a specific step-by-step guide on getting started with Databricks and MLflow for beginners? Yes. You can go to our docs, and there's a quick start for MLflow. You can also go to the mlflow.org website, and there's a quick start there that you can just run on your laptop if you want. Let's see here. Just looking at, okay. Any benchmarking done between MLflow versus competitors like Weights and Biases, Neptune, et cetera? Not that I'm aware of, and I would have to know like on what dimensions you're kind of comparing the two against. So I'm not sure what kind of answer you're looking for there. What are the considerations for PHI and features using these tools? Yeah, great question. Databricks has very, very good security capabilities, both around data access and access controls for models and objects in MLflow, including experiments. So, you know, we have customers in government and healthcare and banking and that are using MLflow. And it's kind of the conversation that you should have with your Databricks solutions architect and your security team on what your requirements are. But we can definitely support PHI and PII and HIPAA data being processed in Databricks and being used with MLflow. Okay, a couple more here. How do Feature Store and MLflow interact with each other in deployment pipelines? So I didn't demo the Feature Store today because I was trying to keep it as simple as possible, but the Feature Store is exciting because if you log models with data from the Feature Store, then the Feature Store actually has the metadata of, you know, what tables are associated with this model and what models are associated with this table. So there's even deeper kind of like metadata that gets attached to the model there. Okay, Christopher Farah asks, have you compared resource utilization of MLflow versus other CI/CD software? I wouldn't consider MLflow to be CI/CD software. I would consider it to be like model management software. And so I think that they're very distinct. But the resource utilization of MLflow in particular, for the most part, is not very high. So MLflow is pretty lightweight for all, you know, for the most part. will connecting WebSockets enable ML algorithms on streaming data? So I'm not sure. So with structured streaming, you can read data from a WebSocket, typically through Kafka, and then you can apply models, Python models, or even R models and Spark models directly on streaming data. That's a very powerful and popular use case, I would say. Let's see. Trying to see if there's any I have not answered. Okay, so there's a question here. Not really an ML question, but if a user reads data from Delta tables to build models, is there a way to give access to only the Delta table and not the underlying files? Yes, you can use table access controls on Databricks. There's a question about Azure ML and ML Flow. There's a wrapper that makes it easier to deploy in one platform, so you don't have to switch. I think that's correct, yes, but I think that's limited to Python. Let's see here. So there's a question, another question. Should the platform be integrated with Kubernetes to provide sufficient dynamic compute for model execution? Would GPU execution also be supported for MLflow? I think for the most part, if your use cases are batch and streaming, or even GPU, then stick with deploying models on MLflow as jobs. If you need like online REST API deployment of your model and you need a load balancer behind it, then I would go with Kubernetes right now. But we are working on something that may not make that necessary anymore. So stay tuned. What is Databricks' roadmap for AutoML? Awesome question. So we recently included the demo I showed with classification. We also have regression, and now we have time series in preview, which is really exciting. And then we're just going to continue to improve upon it and make it more accurate, make it able to support larger data sets, and so on. How do we use feature tools? It's an open source library. Yeah, just Google feature tools, GitHub, and there'll be tutorials for how to use it, stuff like that. Okay, 2 last questions here. So should we consider AutoML to be really efficient when it comes to selecting hyperparameters, or is it a baseline model and the model can improve significantly with the same features? AutoML is pretty efficient on Databricks, and it is both very efficient and it is a good baseline model, most likely. So one of our customers actually, they were in the early preview for AutoML, and they found that AutoML actually gave them a better model, and that's what they're using to power their business right now. So definitely worth checking out. Does it cost extra to use AutoML? No, it is just the cost of the Databricks compute, which is whatever it's whatever the cost is for your company for the Databricks compute. Are you planning to incorporate algorithms like SVM and k-nearest neighbors? Good question. I have not seen anything on unsupervised learning yet, but yeah, good question. Probably not sure. Will the Q&A be included in the recording shared later on? Yes, I believe so. The Q&A should include when we upload this to YouTube and stuff like that. Like all this will be here as well. I think that is pretty much it. So yeah, thanks for all the awesome questions and for the engagement and for your time. And have a great rest of your day. And until next time, take care, everybody.